Hello everyone, welcome to our second tutorial of the semester. This tutorial will focus on importing art and animation. Lights, pixels, panache. I don't even know if I pronounced that right, but oh well. So, I'll give a quick overview about how this tutorial is going to go. Now, since we got through most of the admin stuff last week, we only have to talk about the theory of art and 2D animation, 2D art and animation, and then we'll go straight into the tutorial itself. So I suspect this tutorial would last only 30 minutes or so. As always, if you need to get in touch for asking questions, or if you don't know where to go to get information or these slides, just follow the links provided. Now, today is the 27th of August, tutorial 2, and it's nearing mid-test season. There's just one more tutorial before the mid-semester break, and hopefully after mid-semester break we'll be back in person for in-person tutorials. Now, as a reminder of what I mentioned last week, this semester 2's tutorial will build upon tutorial 1's stuff. So here's tutorial 1, represented by the green box. And there's the same content. However, we're going to build upon it so that tutorial 1 people don't get left behind. The file is uploaded into Unity Drive right now, which you should be downloading. Into the resource drive right now, which you should be downloading. Contain all assets necessary to get the tutorial up and running. We won't be focusing on dragging scenes and stuff around or moving prefabs. All of that's done. We're just focusing on art and animation this time. So yeah, this is represented by the red bigger rectangle. Now next week would be similar, except instead of the art and animation stuff, it would be coding stuff. C# to be specific, but that's for next week. Okay, let's get into sprites and mechanism. Now this is a pretty complicated topic to show without showing the game itself, but I'll give a brief rundown over it and hope to demonstrate to you inside Unity itself once you get to the tutorial section. So without further ado, okay, so art assets, just like every other assets, you drag and drop from File Explorer, the easier way, or you could do the assets import new asset, which is the good old mouse, old-fashioned way, I suppose. But yeah, you do this for all of your art assets. For importing 2D art, there's these things, 2D art at least. 3D art also happens to do these things as well, although the settings are different, keep in mind. Okay, so for pixel art, which is what we're doing this tutorial, there's these 5 settings you should know about. First of all is the sprite mode. That means that, whether this is one single sprite or whether it counts as multiple sprites in an animation or a sprite sheet. One sprite by itself is just called a sprite, but if there's multiple sprites in one sprite, in one picture, then it's called a sprite sheet. Since we'll be slicing the art, we'll have to change the sprite mode to multiple, as there are multiple sprites in one picture. The pixels per unit value is also pretty important. Basically, it means that for each unit inside the Unity is how many pixels in... Oh, I may have mixed it up. But basically it means that the smaller the number is, the bigger the things appear. And for pixel art, this is a pretty important value to change, and keep in mind, you should also keep it consistent over all of your art assets too. Now, for pixel art settings, there's filter mode and compression. These two values are very important for pixel art. Without them, you'll have blurriness or off-palette colors, which you definitely do not want in pixel art. For other types of art like 2D or 3D, it's not so important. relatively. So there's probably different guides on how to do that for textures or terrain or backpacks or whatever items. For now, we focus on PixArt. Slicing, it's in the third red arrow on the right there. Basically means that you could split up a sprite sheet into its individual sprites. For example, shown here is the player bot. The bot picture. Anyways, it's a sprite sheet containing dozens of sprites for the free colored bots. So if you're not sure how to do it, you go on the top left side and then you click slice. And then you choose slice by cell count. Since every cell here, i.e. one sprite, has a set dimensions, we could just pick how many slices, how many counts of sprites in each row and how many total rows and columns are there, and then you could just automatically split the sprites accordingly. After you click on this and click on slice, nothing will happen, of course. You need to click on apply on the top right, or revert if the borders don't align. You can check the borders are aligned properly to the sprites by clicking on each individual sprite. If the box surrounds each sprite properly, then all good. But if not, you have to revert and either choose some other option that's not slicing by cell count, either by changing the cell size if the cells are different sizes and different offsets, or you'll have to do it manually, which is pretty tedious work, to be honest, by changing the boxes for each sprite. Okay, so a little bit about the animation here. Unity uses Mechanim, a tool for animation. It lets you animate an engine within the context of the scene, which is great for designing scenes and animations according to how you want it to. Finite state machines, it may seem complicated at first. In fact, you probably learned this through doing computer systems or software, but basically it lets you control the sprite animations as well as like logic or anything else. But in this case, we'll focus on its use for animation. So looking on the bottom right, is an example of an enemy finite state machine. Now this could be for animation or for logic. It's not really discerned in this picture. I randomly found it online, to be honest. But let's say you start off at the patrolling stage. Okay, so you're doing the patrolling animation. No enemy in sight, therefore there's no reason to change, so it just keeps on patrolling animation. If there's an enemy detected, there will be some code inside the game object telling it to change animation to shooting enemy, for example, and then it plays that animation. If that's a grenade in sight, then you dive for cover, and then it runs the dive for cover animation. And if a grenade detonated, it'll go back to patrolling. So this is a very simple example of a finite state machine. You can see here that all the animation states are included in this simple free circle diagram. Now, communicating like the AI of an enemy is actually pretty difficult if you're just randomly doing things. So that's why things like finite state machines were invented, make it easier to control or like communicate different ideas. For Mechanim, finite state machines, just like for logic, not just animation, it also lets you animate extra stuff. For example, you only have 3 states now, but say you wanted to add like 3 more states. If you weren't using a finite state machine or something similar, it would be very, very well, let's just say it'll cause a lot of pain. Best thing about this is, even if you make it like, even if you put in a lot of states, you can always add in like 1 or 2 extra, and it won't be like a whole nightmare of changing up the entire code to accommodate those 1 or 2 extra states. This is an example of a very simple mechanism animation. So only 3 states here. You see it doesn't actually loop back to the first state, which is the orange state. I should explain that first. The orange state is the default state. Once the scene activates, the scene start functions happen, etc., etc. For this particular animation, the first thing that happens is li run start. You can see how it's connected to entry. That means it's the first state that runs. So the li run start itself is an animation, and this whole finite state machine is called an animator. So there's a huge difference there between the two things. There are many animations in an animator. So in here there are 3 animations represented by the orange and the gray rectangles, and the animator is the entire thing, the finite state machine itself. Now after it now there's an arrow pointing away from the li run start. That means that it will go into li run and no other states. So we don't know what the trigger is, but I can tell you that there's a string trigger here. If you were to go ahead and look at the further slides and actually, I'll show you this later on anyways. It transitions to li run, and then, as you might expect, it jumps whenever you like. Well, in this case, it jumps whenever it does something. Specifically, get too close to the other bot, and then once it finishes jumping, it goes back to li run and then stays there. Example of this could be found in tutorial 1 too, for the player bot. That's a good example of finite state machine to look over too. Now this concept is a bit strange to people who aren't particularly familiar with the mechanism or animation in general. Basically it's a way of putting in keyframes, i.e. key poses or key states for the finite state machine. So this is probably best done by demonstration rather than explaining in words. It's pretty difficult to explain out in words what exactly DopeSheet does and how you actually do it. So I'll give you a picture. So this here's a very simple DopeSheet. In it is one animation called the push bot hit animation. So basically this is only 2 things, 2 key frames. There's the first one and the one at the end. Well, actually there's quite a few at the end, but there's 2 main ones. Each keyframe is indicated by a line, a vertical line descending from the blue bar on the top. You might not be able to see this, but that there's a white line like 1/3 throughout the bar that indicates the current position of the sprite and all those properties, as shown on the blue bot flying in midair on the bottom right. Basically it means that the mechanism is actually animating in between these 2 keyframes. The keyframe on the first, on the left side of the blue bar, and all the frames on the right side of the blue bar. Each horizontal row in this DopeSheet indicates a property of the game object. So you can see that pushBot.position. I'm actually changing the position so it's flying in, well, into space really. Sorry. So you can change the X and Y positions. It's currently hidden in the drop-down menu, but if you expand it, you can see. Once I show you later on in the demonstration and tutorial, that the X value goes from whatever the ground value is to like wherever the high point or the endpoint of the graph is. And same for the rotation and scale. In the demonstration, you'll see that the scale actually shrinks down to 0, signifying that the sprites, like the push part, is shrinking to 0 once it reaches the upper atmosphere and disappears. You could also do many other things instead of just transitions, transforms, position, or rotation. You could, say, change a speed value or a health meter or things like that, not just animation. Okay, now onto the tutorial itself. Oops, that's supposed to be a 2 there. Tutorial 2. So as always, the learning materials are on the drive. This link will be posted on social media, and if there's any questions, just go to us on Discord or any of the other social sites and comment below the announcement. So there's a few learning materials. There's the learning material.rar. Actually, there's a 2 to it. Learning material 2.rar. And there's the slides itself. There's also executable I've uploaded to a drive in case you happen to get particularly stuck and you wanted to see what the final result looks like to get an idea of what to do. Okay, I'll go through these instructions while doing the demonstration one by one, so it's better for learning. So first of all, open up Unity 2018.1.2 F1. The version is very important, of course, through Unity Hub, and create a new 2D project. Drag in all the assets inside the .r to the project window, and that's just like tutorial 1. You just drag it in there. Now, this is the important thing. You want to close Unity, replace the new project settings of the one in the archive, and then reopen Unity. This is so that all the project settings can be carried over from the learning materials onto the game itself. So let's do that right now. So this here is the drive, as you can see. Just go over to learning materials 2.r, download this. You probably want to refer to slides as well, so download that as well. This is the executable. This to help you get an idea of how exactly the game looks like when it's like fully filled out. So we'll just download this. Okay, so here's one I did. Actually, I'll switch to full screen. Hold on a second. So here I'll get out over here, learning materials. I've extracted it, and what I've done was I've dragged all these assets, so select all, drag it into the project over here like this. Now there's quite a, as you can see, there's many files here that's not really exactly relevant to this tutorial, but the main ones to know is scenes, and sprites. Sprites here, these are all the scripts you need, sprites that you need, and then here's animations. These ones are the things, animations that you might consider working on. Just ignore the ones in here for now. You can play around them after the tutorial in your own time. So you would have started off in a sample scene or blank scene. Just delete that scene and then close Unity or exit, and then follow the instructions as I've mentioned in the slides. I'm not going to do it now because that will require a bit of setup, but for you it should be relatively simple. You can name the sample scene whatever you want because you're just going to delete it anyways. So here's the scenes again, and we'll move on to the second part. Okay, so enter the race scene and zoom into the ally animator game object in the scene view. In the project window, open sprites folder and see how many sprite sheet settings is set. how any spreadsheet settings is set. Now copy paste that spreadsheet and slice the spreadsheet so it matches up with the original. This is just to practice the sprite import settings. It may get tedious if there's tons of assets, but it is nevertheless crucial for your game. So I'll swap back to Unity right now. Okay, so I've zoomed into the ally animator game object, which is, I believe, yes, it's this blue bot over here. You can see that it has a ally as its child game object, and you can see that there's a sprite renderer here. If I were to stick in any random sprite here, it will probably change what it currently looks like, but it won't change what it looks like in game because the animator overrides your sprite renderer settings. Alright, so I'll quickly go over how you actually import a sprite. So looking at these settings, sprite mode, pixels per unit, there's the sprite editor itself, as I've shown you earlier. Then there's the filter mode, and there's the compression algorithm. Whoops, is the compression here. So I'm just gonna make a duplicate using the file explorer, because you can't actually make a duplicate easily in the Unity editor itself. So I'll just do it externally. Okay, so I've made a duplicate of this Jellybot spreadsheet. Now notice how the original one has all the sprites split out already. So you can see that if you press the little drop down arrow on the right there, it expands and shows all, I don't know, like 30 or so sprites. This one's the copy I just made. Right now you can see that it does not split up. It actually shows all the sprites bunched up in one single image, whereas this one doesn't. You can also notice how on the bottom right there, you can see all these, like, it's kind of off-colored and also a bit blurry. That's not what you want in pixel art, and it's probably also not what you want in your other 2D or 3D assets if you change the settings wrong. So this is why input settings are very important. So I'm just going to quickly change the settings so it looks like the original. So this is multiple. Okay, I'll leave this setting for later to demonstrate its effects. There's, I'm just gonna test out each of these, see what happens. So right now I'm just gonna go to sprite editor. I'm not sure if you guys can see this considering this opens up a new window. So I'll quickly. Okay. So as you can see, there's some really off-colored pixel art sprites. That's not good at all. If you change the filter mode to point and the compression to none, it will suddenly look a lot better. That's because sprites is heavily affected by, well, pixel art at least, is heavily affected by filter mode and compression. You don't want pixel art to get compressed or also look ugly. So if you follow the slice here on the top left, go to grid by cell count. And let's see, there's 6 by 6, so that'll be 6 columns by 6 rows. Slice. Now you might have barely seen a change, but yeah, as you can see, it's a bit off there. So you'll probably have to adjust the grid by cell size instead. So let's see, I believe it was 14 by. I'm playing this off memory. I might accidentally get it wrong, but if so, I'll just revert to the other one. Bit better, but yes. Okay, so it seems there's an offset in between these two sprites of approximately 1 or 2. Oh, whoops. It's not offset. It's padding. There's a padding in between each sprite. Oh, well, good enough. Most of it's in here. I probably manually had to adjust some of this. If you wanted to adjust this, what you do is you click on the square and then you expand it, and then you adjust the sprites like so. There's the green box, as you can see, actually represents the, I believe, the stretch. Sorry, the border of the sprite. Whereas the blue little circle over here represents the overall sprite size. Okay, so let's just say it looks good, and we'll just quickly apply it, just so I can show you the rest of the fix. Okay, so right over here, I'm just gonna say, oh look, let's just drag one of these guys here. You can see, oh, so tiny. So that's because of the pixels per unit tag here. In each unit of Unity, there is 100 pixels. This little guy takes up 16 pixels inside the image editing program. However, you don't want it to be, well, in this game we don't want it to be 100, so we change it to 10. And oh look, now he's a bit too big. But that's okay, because as you can see from Ally Animator, he's actually scaled down to 0.5. So we just change this copy to 0.5 and it should be roughly exactly the same look. Yep. Okay, so that's how you import a sprite. I could adjust the bilinear and compression settings. You can see that. You can already see that it's pretty blurry. It's because it's compressed image. If we change the compression, you can see that. Oh, it might be a bit hard to see from here. I'll use another picture. Let's see. You can see that some weird, like, off-color images appeared. That's why it's important to have no compression when using pixel art. In fact, if memory isn't a concern for your game, you'd also want to use preferably lower compression, assuming the format that you're using was lossy, because it may give a better performance. Usually it doesn't matter if an object is moving fast, so you can't really notice the compression, or if your game requires lots of performance. But yeah. So I'll just delete these two pictures. Alright, so that's how you import a sprite. If you want to import, oh right. Okay, so you say you want to add an animation. This is what you do. It's pretty simple. You just select a bunch of sprites, drag it into the hierarchy window, and then it'll let you create animation. Okay, so yeah, you can see this window. Yeah, just make a new animation. I won't actually make one here. I'll go back to the minigame. So you've imported a sprite. Great. You can see that the settings are exactly the same as the other one. And that's what you want. Okay, now I'll just quickly delete this. Okay, on to the next slide. Okay, so we've done the sprite sheet stuff. On to the next thing. This tutorial is split up into 4 quick mini-games. The first one is race. Looking into the animator view of the Ally Animator game object, change one value in the transition. That's the arrow between the rectangles to get your blue robot running. Okay. Just resize my windows here. Alright, so if I click play, oh no, the red robot's getting away. You see, the race is between your blue robot and the red robot, and you have to get to the blue tram line first. Now let's see what the animator says. Okay, it looks just like the image we saw earlier. Looks pretty good. However, you can see here that is sleeping, and if you were checking around earlier, you can see here, oh, is sleeping is false. Now let's see what happens with a Mecanum. This is Mecanum Finite State Machine in action. You can see here that it never actually goes to ally run, and that's because of this animation here. If I were to set to false, he will finally start running. That's because the conditions here, if the is sleeping is false, then it will keep on running. And it will transition from this state to this state. However, as you saw earlier, the sleeping is actually changes to animation is permanent inside the play mode, so this is what it was originally. So if you see here, it doesn't actually transition, but that's because the condition here is sleeping is false. This is the condition required to transition. On the left side here, you can see here that is sleeping is true, so that means it will never actually go to ally run. Now to solve this minigame, you can either play around with yourself, or I'll just tell you the answer straight up. And that is, you change this sleeping condition to true, because you want the character to wake up. That's exactly what ally run does. So, press play. Your blue robot is finally moving. Oh. I moved the scene here so you guys can see what's up. So your blue robot jumps over the red robot and makes it first to the tram. And that's the first minigame done. Let's move on. Nope, to the game scene. Alright. So you see here, this is the next minigame. You see a blue robot, this is your robot, and this is the red robot. On to the next scene. Alright. Since this tutorial is going to take up a bit longer, I'm just going to quickly speed it up. The second one is called Dance. You look into animator of the ally animator like before, and you'll find unconnected animation states. Your goal is to match the blue robot's moves with the red robot by connecting states in the right order. And also, the transition time is pretty important. Although that won't be checked, it will still let you better match the red robot's movements. There's a missing animation also in the sprites animations folder that you have to look out for. Okay, so back to the dance scene. So into the animations folder, sprites animations, and looking here, you want to go to the ally animator of this one. Okay, so it looks pretty jumbled. You could ignore these two, they don't do anything. But basically we have to connect these three scenes. Now let's see, if we look at the existing transition, where you can base off your future transitions off, you can see that the exit time is 1. Transition duration, 0. Remember these two values because you'll make it for every other transition you make. So, as you saw from before, entry goes to ally moonwalk. Okay, let's see what that does. Okay, so it seems to move the sprite backwards, the ally backwards while facing forward, like a moonwalk. What do you know? Now this will be pretty tough to do because it's pretty fast. So we'll go into animation and see what each sprite animation actually does. So you see here, ally moonwalk. If we go to the scene view and you press this play button over here, yep, that looks like a moonwalker, right? You see that it transitions to the ally pose. There's no conditions listed here. This is empty. Therefore, it will automatically go to ally pose once moonwalk completes. So let's see what that one does. This one's a pretty short one here. So it does a jump and does like a kind of like kick animation. Alright, to show again. Yep, that's the second animation. Now, if you want to work it out on your own, I suggest you pause this video, or you could stay and watch the answer. Although I highly suggest you work it out on your own because it's pretty fun. Alright, so first of all, there's ally jump, then make a transition here. Remember to change the settings. Exit time 1, duration offset 0, no conditions. Jump animation is this one over here. So he basically just does a giant leap on the field and lands head down. Okay, let's see what this does. Yep, that looks about right. Okay, I'm just going to repeat for the other ones. So there's ally flip, exit time 0, transition duration 1. This is kind of a strange one. Basically it does this. And for moonwalk 2, yep. Okay, let's see what this does now. Oh, there seems to be one more missing animation, and that is one of these. One of these 6. So in the project window, an animator is depicted with this. There's multiple rectangles and a play button. Each animation, i.e. one of the rectangles in here, is depicted as one of these, with a play button only. So let's see which one's missing. Okay, ally flip is over here, ally jump, ally moonwalk with no number, ally moonwalk 2, ally pose, and ally pose 2. Okay, so this one's the missing one. So we just drag it on here and make that transition. 1, 0. Now, unless there happens to be a big bug, this should work. You can see here the states moving one by one. And minigame 2 complete. This one. Oh, what did I do? Oh no! Oh no, I died. Okay, so this one's the push-off challenge. On to the next scene. So this is minigame 3 and 4, bundled here in this one slide. Minigame 4 is just show. But minigame 3 is push-off. So in the animator of the pushbot animator, there's an unconnected pushbot hit animation. You'll need to pass this pushbot and get to the door on the other side. How you do that, however, is by changing the animator so that the pushbot will be defeated, or at least moved far away. So let's look at that now. Once again, go to the pushbot animator. This time it's the pushbot, not the ally bot, because there is no ally bot. Alright, so this here, these two can be ignored as always. Oh, not as always, but for this tutorial, yeah. So entry goes to pushbot start. Now let's see what this animation does, so we know what to look at. Make sure you select pushbot in the hierarchy window, then choose whatever animation you want to play here. notice and a reminder that I have my scene view on the right side so I can see what each thing is playing. If you click on the game scene, you see that it may be a bit blurry if you make this window too small. Okay, so click on play here. It's a start animation. Then he moves to the push animation as he slowly inches forward and preventing you from passing. And if you try to walk up to him, you get killed. So let's see what happens here. Now there's many ways you could complete this challenge. I'll show you the easiest way to do it, which is just making one animation. So you can hear that he's slowly inching forward in the scene view. This is push bar push. And he makes this animation. This is the intended way to do it, but you don't have to do it the intended way. Fortunately, you could like make this miss around or whatever. And if it works, it works. Alright, so this one's the push bar weak animation. During this time, I could give you the answer straight up, or you could, you could figure out the answer yourself, or I'll just give you the answer straight up right now, which is making a transition from push bar to hit. And you'll see that the hit animation actually does this, therefore allowing you to pass into the goal, which is the sparkly things over here. For completeness sake, I'll show you what push 2 does, and you can see that if you wait too long, he'll just, kick you outside to your doom. Oh, I'll just play that and see what happens. So those, if you fall into water, you die basically, and you have to press R to reset. Oh no, he's coming closer! Huh. Oh. Well, I totally didn't intend for that to happen, but it seems like I made a transition with no conditions. That's certainly one way to do it. Okay. That's more like it. Alright, to show you push bar 2 again. Oh, not again, but for the first time. Once this push bar weak shows, goes straight to push bar 2, by then it's too late for me to hit him, and then he kicks me out. Oh no. Okay. However, this is triggered by code to change from this state to this state instead. So whenever the robot is in push bar weak and he gets hit, transitions to push bar hit, which means that I can pass safely. So let's see what happens when I do that. Okay, press and hold left mouse button or Z to shoot. And gets blasted off to space. And this is the final scene. You could check this out yourself. There's no mini games there, but it's just something fun to see. For now, I'll just quickly go over the dope sheet stuff and see if there's any other potential ways you could solve this problem. Of course, there's the the hacker man way where you could just go, oh, I'll just make this the default state. Wow, that was easy. Of course, there's other ways you could do it, such as such as changing the dope sheet itself. So, I'll give you a brief example into how the dope sheet actually works. So you can see here this one's pretty complicated. Basically, he just inches forward. Oh, this is push bar 2. Or push bar 1. Okay, so he kind of slightly bobs up and then moves forward. And then there's that little puff animation, smoke. Okay. So let's say we wanted to move him out of the way. Well, why don't we just change the y value to like, I don't know, what's over here? It's like 5 on the y-axis. So we just do that. That's definitely further enough. And okay, what happens now? Okay, great. He just teleports up there, but then he goes back down again. And the reason why he goes back down again is because you have to make, because the third keyframe, sorry, sets his position back down to 0. That's how dope sheets work. You make a keyframe for each animation, and they define the movement, and Unity will let you blend through in between each animation if you let it. Now you see here that the movement was kind of like pixely, well, like instant change. So you can see how it instantly jumps up and then jumps back down. That's because I set the curves. By the way, this is a bit complicated, well, a bit advanced for a beginner, I believe. But basically what I did was click on one of these points. Each of these points represents a property here, each diamond. If it has a float value, then it will represent here. So this represents the height, jumping up to 5, and then immediately after the next keyframe happens, it drops down to 0. So if I move the scrubber, by the way, this blue bar and the white line, that's the scrubber. It plays the animation. You can see that goes up, stays up, then drops down. However, if I wanted to make this smooth, like in non-pixel art stuff, then just go, oh, let's say I want clamped auto. And then I drag the arms. Oh, well, I need to change the other ones. Clamped auto. Okay, now this curve looks a lot more like organic. And you can move up and down to change the height value if you want. Doing so also changes the Y position here. But what I really want to see is changing these things over here. So you might recognize, if you've done a bit of math, that these two lines are actually, well, these two handles on the left and right of each point is actually the tangent to this curve. So you can see that if I make it vertical, oh look, it's a straight line. It's like a square wave. Do the other way around. Same thing. If I make it flat, means that it's exactly 5. It will reach the maximum at this value, derivative of 0. You know, math kind of stuff. Okay, so let's say I want to make this weird looking. Let's say I want to jump really high and then go below the value afterwards. So this could be shown by this. You can see that keyframe is still the same. Oh, well, not this one. But these 3 points, keyframes, still exactly as I set it. 0, 5, 0. However, by changing the tangent and making the movement a curve, it will end up like this. Now, this is the key thing to know for all animation. By changing the curves, you can make something look cartoony, realistic, or just, you know, plain like crazy. However, a good animator will know how to curve each movement properly. As for me, I'll stick to my constant waves. Excellent. Okay, now we don't want him flying out into space. If you want to change more properties, alright, each of these is a property. Position, position.x. Sprite, sprite enabled, sprite. Say I want to change the let's see. Let's say I want to disable the collider. If I turn this off, that means that the robot will literally like fall through the floor because of gravity. So let's see what happens if it's with it existing, acting normally. Okay, good. Collider disabled. Nope. Alright, there's a key thing to mention for this. It's kind of a tedious, but you have to move the scrubber to where you want to change the value. You see that over here, there's no like diamond. If I press enabled, it creates a diamond where that point is, but I don't want that, so I'll delete this and move the scrubber back to where I want it before changing the value. Okay, so enable. Yep. Oh, I just realized the gravity wouldn't be simulated in the scene view, so I'll just go to game view and see what happens. Okay, so collider works. If I turn off collider, oh, hold up. Okay, I'll backtrack on that point. The animation literally sets out the positions. That's right. Each keyframe here is manually set in stone. So no matter what I do to the physics or whatever, it wouldn't move it. So even if I added a force to it, it won't move because the key presses here, the animation takes over the physics. So that's something very important to know. Yeah. So just to recap, because Adobe Sheet's a pretty complex topic, horizontal axis represents time, vertical axis represents each property you want to change. By moving the scrubber, the white line, to a specific point and changing the value, say changing this to y position to 5, you can see that it moves up. So each of these is a keyframe. If you want to make more fancy moves, you go to the curves and then you change to, say, clamped auto, or basically a non-constant. Okay, and that's minigame 3 done. I'll just quickly... Oh, right, I realized I turned off the collider. Or something happened. Oh well, on to the next scene. Now the fun thing is playing around with the animations. With these animations, although it's a bit hard to get into, I should say, build settings, the fun part is adjusting the dope sheet to make some new animations. It's a bit difficult at first, trying to understand how you put in sprites into the dope sheet, but it's basically the same as adding any other property. You just click add property, go to the sprite renderer, and then drag some sprites there. I'll give a quick example to that after I finish these slides. But yeah, with animations you can do many things. Fluid movement, you can make camera bobbing movement, or many other things. I'll leave that quick demo till after. Alright, so if there's any questions, visit us on social media site and voice chat on Discord, Facebook comments, Twitter comments, Twitch comments. Yeah, these are the sites. These are the links again. These credits, same credits as before. Slides Carnival slides, graphics kid, creating this awesome pixel art for public domain, and of course it's the blocky text. Alright, so a short little. Okay, we'll quickly go back to the push off one and see how you could change the sprites. So push bot. Okay, let's say we want to change the sprite. Let's say we don't want him to do the shocked face and fly away. And say we want to put in a different sprite. So what we do is go to blue bot. Oh, let's pick a random one. This one looks appropriate. If you want to replace the sprite, this is what you do. If you just drag it anywhere, this is what happens. Okay, so you can see that the sprite first of all created a new keyframe here in this dark gray bar, and you can see that it switches to the different sprite on this exact moment. If you wanted it to just be there from the beginning, you just drag over and replace the existing sprite. And off he goes. Also, say you realize, oh, this animation is pretty slow. We want to speed it up. Well, to do that is simple. You just change this to, say, a higher value. 40 samples per second. By the way, this is samples per second. So each sample now takes like 15 milliseconds. Okay, click play. Yep, that's definitely faster, right? And I think, yeah, there's one more thing to talk about. That is each animation. You could have it either loop or not. If it loops, then it'll infinitely play it until you change to a different animation state, as shown by the running animation from the race scene. But for this, say we want this push bot hit to loop for some strange reason. If we were to do that, and we do the hacky way and just go straight to default here, you see that the hit animation just continuously loops. So that's something to keep in mind. Oop. Here it is. Okay, push bot loop. If you wanted to loop at an offset, say, okay, so there's, I don't know, let's see. Alright, it loops based on time. So say you want to loop at a different portion of, or loop at a different start portion. Well, that's something to figure out, I guess. Let's see, I believe it was 1 point. Oh well, that's something to play around. I keep this at 0 usually, unless you're going for some special run animation. For loop pose, is specifically if your animation wasn't originally looping well, and this makes it loop seamlessly. Of course, for this hit animation, that's kind of pointless. But basically, Unity automatically makes your loops seamless. That's something important to know if you're making loopable animations, but you don't want to make it like seamless. If you're not too worried about quality, then you can just put this setting on and it'll be automatic. And that's about it. So that was Game Developer Guild's Tutorial 2, Semester 2, Importing Art and Animation. Hopefully you had a good time, and see you next week.